Hello everyone to my YouTube channel Quantum Pieces, and in this YouTube channel we will be exploring the realm of science and technology, and mostly the content will be based on quantum stuff. That's it for the introduction. For my first video I will take quantum computing as my core subject to explore different branches of mathematics and physics throughout this video series because exploring all the branches of quantum mechanics and quantum computing is not sufficient in a single video. So, what is quantum computing? According to IBM, quantum computing uses specialized technology, including computer hardware and algorithms that take advantage of quantum mechanics, to solve complex problems that classical computers or supercomputers can't solve, or can't solve quickly enough. If you have no idea what the definition means, that's completely fine because now we are in the beginning of this session, so we will not be discussing some difficult terminology, and the beginning path will be smooth and more easy to grasp, and through all those small ideas we collect on the way help us build a strong foundation for understanding quantum mechanics or even more the nature itself. So in simple terms, quantum means a small or discrete body like an electron, that is a microscopic body. It is important to note the word quantum or microscopic bodies because this body tends to follow the laws of quantum mechanics, which is the branch of physics that developed in the early 1900s, not being specific with date. So, we will be using such a microscopic body as the major entity for controlling the computing, and that defines quantum computing. Computing and computers are different, and it is necessary to first distinguish them. And the short description would be computing is any operation on a computer. So to understand computing, first we need to understand computers, that will be quantum computers. We can relate quantum computers with our PC or classical computers by asking a question. Is a quantum computer different from classical computers? So, the simple answer is yes, it is different in many ways, and how can we say so? It can be illustrated through the data in the table shown in the animation. Further, we can take an example to understand it in a much better way. We can exemplify classical computers as cars. Car is quick and we can use it to travel on the road, and it helps to take loads of passenger at the same time, but what if I want to cross the continent or go beyond? Then I certainly would need something that might or mightn't be quick then, but that should be efficient to travel across sea, and that is boat. The boat we now call the quantum computer. It is quicker than classical computers in solving many complex problems. Therefore, we need a quantum computer. When I mentioned complex problems, the best example could be modeling the behavior of individual atoms in a molecule. It is a complex problem because all of the different electrons interact with one another. Yeah, I know some of you mightn't understand the problem, and again, there is no problem with that. Moreover, the easy definition for a complex problem for anyone who has experience in mathematics would be any equation, especially a differential equation with lots of variables in it. Now, we know a lot of important quantum stuff. We will be slightly discussing quantum challenges scientists are facing in building it, or simply saying we are discussing its limitations. Firstly, we need to understand the state. So, state is position, and it is believed that in PCs we use the transistor that takes either 1 high or 0 low state at a time. Therefore, we say classical computers use a bit that is a binary 2-digit. But in a quantum computer, all the possible states that lie between 1 and 0 are taken by the quantum computer, and it doesn't mean that it takes 0.1 or 0.2, but it means that it takes multiple states at a time, which is called superposition. Now, understanding this simply helps us dive into one of its major limitations. Quantum computers are sensitive to noise and difficult to calibrate. Unlike traditional computers that would experience a bit flip from 0 to 1 or vice versa, quantum errors are more difficult to correct because qubits can take an infinite number of states. Does it mean quantum computers are useless? Obviously not. Everything has pros and cons. Similarly, everything has limitations along with a variety of usefulness. Since it is in its early stage, we have a lot of difficulty and problems, but with proper research and resources, we might come to a day where quantum computers might be the reason for many new discoveries. I would have loved to discuss cryptography and encryption, which are underlying topics of quantum computers, but it has its own logic and sets of rules, so we will look towards those topics in coming videos. So that's it for today's video. Thank you for staying till the end, and I hope you enjoyed the video and got to learn something new.